This video will introduce the third pendulum modeling method in MBDyn, which will involve a new type of node that is called static structure node and two new constraints, clamp constraint and distance constraint. As in the previous video, two coordinate systems need to be established, named the pendulum and mass respectively. Different from the previous two methods are the nodes and elements. This abstract process is worthy of careful experience. First, create a static structure node and place it on the pendulum coordinate system. Note here, the angular velocity is taken in the global coordinate system, which means that this node has no initial angular velocity. Drawing through the OR method, you can understand this immediately. Then, create a dynamic structure node and place it on the mass coordinate system. The angular velocity is still based on the global coordinate system. That is, the dynamic node also has no initial angular velocity. Place the body on the dynamic node. That is, assign the physical properties to the mathematical information. Here is a new constraint, clamp constraint. Clamp constraint is a constraint who let the node can't move. The clamp constraint in life is like this. In this example, a clamp constraint is used on the static node to fix the node. The node here is the keyword of MBDyn. According to the official instruction, its function is to make the constraint joint use the same position and coordinates as the related node. Another new constraint in this example is the distance constraint. The trajectory of a rigid pendulum is a circular arc, or a full circle. From a mathematical point of view, a circle is a collection of all points on a two-dimensional plane that are at the same distance from the center of the circle. Therefore, a fixed distance constraint can be imposed between the pendulum node and the mass node, so that the mass dynamic structure node always maintains the same distance relative to the pendulum node during the movement process. The rigid body pendulum model can also be established by this method. Note that the two nodes of the distance constraint are in order. If the order is exchanged, the position information in the MOV file will not change, but the reaction force in the JNT file will be reversed.